Hello, class. We are working on 10D transformations, part 1. All right, now, whoa. Let's see here. Okay, 10D transformations, part 1. Enriched Algebra 2, we've talked a little bit about the fact that we can move any of these functions, left or right, up or down, make them like narrower or wider, which is like steeper, not as steep. Now, we've talked a little bit about how to do that, but here is like, hopefully a more like official summary of everything. Okay, so let's tackle this. All right. So now, okay. Up or down? Up, you add a number to the end. Down, you subtract a number after the equation. Okay, for example, you pick any equation at random. So you just anyone, close your eyes and point to one, that one. Square root of x. So y equals the square root of x. Up, you want to add something. Down, you want to subtract something after the equation. So for example, that would move it down 2. This graph is now moved down 2. Okay, that seems fairly straightforward. Now, to move something left or right, you may have noticed, is weirder. So the easiest way to remember this is you replace x. So wherever the x is in the equation, you replace x with, okay, to move it left, you're adding a number. To move it right, you're subtracting a number, which seems backwards. Okay, so if you start with an equation like the square root of x, you replace x with x plus or minus some number. Okay, and plus is going to move it to the left, minus is going to move it to the right. So take out the x and replace it with something like x plus 3. So plus moves it to the left. So plus 3 moves the graph to the left 3. Okay. To flip something horizontal, by horizontal, I mean so like if it's here, the graph is here, a horizontal flip would move it over to here. So that's flipping it horizontally, or sometimes I'll refer to that as sideways. To flip something sideways, you put a negative inside the equation. In front of whatever x is. In front of, let's see here. So for example, so this one, x in front of the x. So the x has become x plus 3. So, or what x has become. Okay, for example, y equals the square root of negative x plus 3. So that is going to be a horizontal or sideways flip. A vertical flip, I'll refer to that if you want to flip it vertically. So that's like if you have a graph here and you flip it vertically, it would go here. So that would be your vertical flip. Or sometimes I'll refer to that as upside down. Okay. Vertical flips are more common, and you put a negative in front of the formula. In front of the formula. Okay. For example, y equals negative square root of x plus 3. That would flip it vertically, or upside down. Okay. So, what this is saying, if you take any formula and put a plus 3 at the end, no matter which formula you do it to, it goes up 3. For example, y equals the sine of x plus 3. Okay, this one, x minus 4, is in the formula. So minus moves it to the right. Remember, it's kind of backwards. So that x minus 4 is going to move it to the right 4. For example, you pick a formula at random, like the cosine, and you put x minus 4 into it. That moved it to the right 4, so it's inside the formula. So like this x plus 1, that's in the formula. That's going to move it left 1. For example, if you pick a random formula, like the absolute value of x, y equals the absolute value of x plus 1, just moved it, it's a little sloppy, left 1. Okay, the negative in front of any formula flips it upside down. For example, if you pick a formula, like the absolute value of x, this would flip the absolute value of x upside down. So rather than the v going up, the v is upside down. F of negative x, that's a flip sideways. So if you have y equals the absolute value of, say, x plus 2, and you flip that sideways, it would look like this. So the absolute value of x plus 2, that's a v. Now, if you flip it sideways, this half goes over there, and this half goes over there. So this half goes over here, and this half goes over here. Notice what it looks like. So this half goes over there, and that half goes over there. It looks the same. So if this is your absolute value like that, and you flip it sideways, it looks the same. The same would be true for a parabola. Parabolas are U-shaped. If you flip it sideways, it looks the same. You can't tell if it was flipped sideways. Interesting. Okay. So, are you getting the hang of how to write these? All right. So this negative flips upside down. This moves it up 4. So how would that look? So you need to put a negative in front of the formula and a +4 after the formula. So you would get, and this is just function notation, that f of x is the same as y equals. So negative the square root of x plus 4. All right, the next one, this flips it sideways, that moves it up 4. So you need to put a negative in the formula in front of the x. So you would get f of x equals negative x cubed plus 4. The +4 moves it up 4, and the negative flips it sideways. Can you tell in a cubic that it was flipped sideways? So this half would go over here, like this, and this half would go over here like this. So this is the cubic flipped sideways. So yes, you can tell. All right, let's try the next one. So x minus 1 goes in the formula. So that would look like this. F of x equals the sine of x minus 1 plus 2. So this moves it to the right 1 up 2. This one, 2 to the x. That's exponential growth, which we talked about this year. That wasn't one of our main functions up here, interestingly enough. I am aware of that. So these are the main functions we're going to be working with this chapter. This was not one of them, but you still should be able to put an x minus 1 in it and a plus 2 after it. So that would look like this. F of x equals 2 to the x minus 1 plus 2. So this moves it to the right 1 up 2. Okay. Make sure you see the shape of the parent function and look at the transformation. Okay, so graphing examples. So like this problem. Now, this has been moved to the left 1 up 2 and flipped upside down. Okay. If you know the shape of the parent function, we should be able to graph this now without a table. Okay, so our parent functions, the parabola. All right, the parabola has a vertex at 0, 0. Then the first point is over 1, up 1, over 1, up 1. The next point on the parabola is over 2, up 4. Over 2, up 4. Okay, so now the vertex that was at 0, 0, it went to the left 1, up 2. So left 1, up 2, so it's there. That's my new vertex. It went left 1, up 2. Now it's flipped upside down, and it has the same shape. Changing the shape, there's a number in front. There's no number in front here. Okay, so now I'm going to go, instead of over 1, up 1, I'm going to go over 1, down 1. And it does the same thing on the other side, back 1, down 1. And over 2, down 4. Over 2, down 4. So there's my parabola with no table needed. Now, if you're not sure of something, you can double check this with a table. Like if you plug -1 in, you should get 2. We could try that to double check it. All right. The absolute value is V-shaped. It starts at 0, 0. It goes over 1, up 1. And it's just straight. So it goes over 2, up 2. It goes over 2, up 2. Over 2, up 2. Just a constant rate of change. Okay, this graph has been moved to the right 2. And then it goes over 1, up 1, over 2, up 2. It does the same thing on the other side. So there's my graph, no table needed. And you can double check, like if you plug it in 1, 3, you should get 1. You can check that if you're not quite sure. Now the square root graph is the hardest graph. That starts at 0, 0. It's half of a sideways parabola. So, over 1 up 1 is still over 1 up 1. Over 1 up 1. Now the next point, over 2 up 4, gets flipped. So now it's over 4 up 2. So my next point on my parabola is over 4, 1, 2, 3, 4, up 2. That's the shape of my parabola, half of a sideways parabola. Okay, now, my graph has been moved to the left 2, down 1. So my graph has been moved left 2 and down 1. That's where it starts. Left 2, down 1. Now it's flipped upside down. So instead of going over 1, up 1, it goes over 1, down 1. Instead of going over 4, up 2, it goes over 1, 2, 3, 4, down 2. So there is my new graph. All right, so you're trying not to use a table. All right, so give those a shot. If you have any questions, we'll try to get that worked out. Good luck.